Welcome to God's Design Physical World. You're about to start an exciting series of lessons on physical science. God's designs for the physical world consists of machines in motion, heat and energy, inventions and technology. It will give you insight into how God designed and created our world and the universe in which we live. Lesson 1: Introduction to Machine Energy. Machines in Motion. What is mechanical energy? Before we define the word mechanical energy, let's learn some words to know. First, mechanics. Second, mechanical energy, and the physical law. Have you tried to imagine what the world would be like if nothing moved? It would be a very boring place, isn't it? Thankfully, God loves motion and created a universe full of movement. There are certainly times to be still. In Psalm chapter 46, verse 10 says, "Be still and know that I am God." However, the world around us is in constant motion. The scientific study of motion is called mechanics, or the study of mechanical energy. In this book, you will learn about the different ways things move, why they move, and many ways to use that motion. Motion can be in a straight line or in an arc. If something is moving around an axis, it is said to have circular motion. Gravity plays a large role in how things move on Earth. So we will be studying gravity in this book. Now, mechanical energy is one of the most visible types of energy. Other types of energy include chemical, electrical, light, nuclear, and thermal. Unlike chemical, nuclear, and electrical energy, which all take place on a microscopic and atomic level, mechanical energy is easily seen, measured, and tested. You see things and people move all around you. Mechanics. As we define the word mechanics, it is the scientific study of motion or the scientific study of mechanical energy. As we learned from our previous lessons that mechanical energy is the position plus the motion, and mechanics is the movement of the thing. It is a movement of the thing around us, and we can see it through our eyes because it is very invisible. So, mechanics is a movement of a thing, and we understand that thing moves in many ways and in many reasons. For example, a boy wanted to return the books to the library, and he needs to walk or move to return the books to the library. And as you can see, as you can observe that the boy is walking straight to the library. And that is motion. And another way, if the boy's house is at the back of the library, the boy might turn into arc to get the library. And that is motion, that is mechanics. As we learned from our previous lessons that motion can be a straight line or an arc, or sometimes motion is moving around an axis and it's said to have a circular motion. What is mechanical energy? As we define, mechanical energy is the scientific study of motion. In other words, mechanical energy is motion plus position. Now we can see around us, if we look at on the road, we can see cars are moving. And even now besides you, your friends or someone's moving around you. And one example of this is rubbing hands. Do you know that rubbing hands together converts mechanical energy to thermal energy? Now we will find these things when we go to the next page. Let's learn more on mechanics. Mechanics deal with how the actions of force affects material bodies or functional parts of an activity. Let's take an example of mechanics is the distance it takes for a car going 30 mph to stop. As we observe that the car is moving and it shows off the force affected to the car's body and the functional parts like the engine that makes the car to move. Like all forms of energy from a scientific viewpoint, mechanical energy is the ability to perform work. Yes, we know that we have energy. If we don't have energy, we cannot do anything. We can talk, we can work, we can walk, we can play because we have energy. You perform work when you move something. Like for example, if you move a book from one place to another, that is, you are exerting energy and you're doing work. You use mechanical energy in countless ways. You use it to brush your teeth and comb your hair. You use mechanical energy to ride a bike or mow the lawn. Mechanical energy swing a bat to hit a home run and allows to slide down a snowy hill. People have also learned to build machines that allow them to do much more work than they could without the machine. Using a machine to increase your ability to do work is called mechanical energy or mechanical advantage. Mechanical advantage allows people to build bridges, skyscrapers, aircraft, carriers, and airplanes. You will enjoy these lessons once you learn how we can use mechanical energy in our daily life. Now, how can we use mechanical energy? Yes, we can use when we are brushing our teeth, when we are combing our hair, and when we are riding a bike, or even when we're walking. Or like the sportsmen when they're batting the ball and hit the home run, that exerts or they're using mechanical energy. All the things that we're doing in our daily life are involved with mechanical energy. And now we will learn more about mechanical energy in our next pages. Let us define the word energy clearly. Energy is defined as the ability to do work. Energy is conserved. There are many different types of energy, such as kinetic energy, potential energy, light, sound, and nuclear energy. Now, how and when do we need energy? We need energy when we do something. Like if we move this apple into one table to another table, we need energy to carry this apple. And that energy gives us the ability to perform work. Physical laws. All objects in the universe move according to the specific laws. For example, all objects obey the law of gravity. Everything on the earth is pulled toward the center of the earth. As we learned that God created the world and the universe with constant motion, and God created the universe with the perfect movement, so that each object is smashing each other, and that law is called physical laws. Let's watch this video clip for more understanding about how the gravity pulls the object towards the center of the earth.
Newton thought that if an apple falls from a tree, it was because some force must be pulling it to the ground. He reached the conclusion that objects are drawn to one another, and that the Earth is so big that all objects are pulled towards it. That's why, if we throw something into the air, it always falls to the ground. He deduced that this same force was what made the moon revolve around the Earth. According to Newton, the moon is moving in a straight line, but the Earth's force of gravity is constantly pulling it towards it. But why doesn't the moon crash into the Earth then? Because it's too far away. It's at the right distance to be attracted by the Earth's gravity without being stopped in its tracks, just as if it were being held by a rope.